All right, guys, let's get back to work.
Hey there, how's it going?
Oh. Hello, who are you?
I'm Salamander, client for this axolotl project.
I'm Devin Cell Biology. Nice to meet you.
Nice to meet you.
I'm standing in for the boss today since he's out sick.
Oh, I was wondering where he was. Well, I was just coming in to see how everything is progressing. I thought the project would have reached adulthood last week, but I heard there was a delay.
Yes, we've been tweaking some last minute things, making sure development is progressing properly and building an arm. Should be done here soon.
Wait, building an arm? I thought that was completed ages ago during embryogenesis.
Yes, well, we were told to build an arm, so that's what we're doing.
You were told? Can't you see that there's already an arm here? Why do we have a blastema here 1 week before launch?
Well, Brian from Nervous Systems sent us from some FGF8 and SHH for the wound, so I assumed that we were supposed to build a new arm. After all, he said that you were the one to approve the order.
Okay, but that still doesn't make sense. Why should getting FGF8 and SHH matter for building an arm?
Let's start from the top. So, Miss Sal, in order to get this whole
Very
regeneration
cool,
process going, we're going to need a couple special growth factors depending on what kind of cells we are attempting to start the regeneration process in. If we're dealing with regeneration involving blastemas that only contain anterior tissues, the process will be different than if it was involving blastemas that only contain posterior tissues. The all-anterior blastema typically regresses. However, it was discovered that stimulating hedgehog signaling by using smoothened agonist would prevent this type of blastema from regressing, and it would also cause the limb to regenerate with clear skeletal patterning and all the appropriate limb cell types associated with this limb. It was also discovered that if you add a posterior tissue graft to the anterior blastema but blocked hedgehog signaling using cyclopamine, then accessory limb outgrowth from the anterior blastema would not occur despite there being posterior tissue there for the anterior blastema to work with, thus further indicating the importance of hedgehog signaling in anterior blastema limb outgrowth.
I actually don't think she's listening to me right now. I'm pretty sure she's completely in outer space, like not at all paying attention, but I'm gonna keep explaining because she needs to know.
Yeah, I don't really know what he's talking about. But it's okay, as long as I get what I want.
But what happens if you cut off the newly regenerated anterior blastema-derived limbs, aka the sagals, and then let the wound try to regenerate on its own, you may ask? Well, unfortunately, the axolotl will either not regrow the limb at all, or it will grow a spike instead of a limb, which suggests that these regenerated limbs retain their anterior determination state. It was then found that transplanting the sagal tissue would result in limb outgrowth in only posterior wounds, thus further solidifying the previous findings. These results tell us that SAG promotes limb outgrowth by upregulating a downstream growth-stimulating signaling loop that's involved in limb development. On the flip side, for the exclusively posterior blastema, which notably also regresses unless complemented with anterior tissues, SAG was not able to induce them to make accessory limbs. It was then noted that hedgehog signaling pathway factors such as GLI1, PTC1, sonic hedgehog, FGF9, and FGF10 were expressed in posterior blastemas with or without SAG, which means that although the hedgehog signaling pathway is intact in this type of blastema, it is simply not enough to induce regeneration in this context. To solve this issue, it was found that just inducing FGF8 expression in these blastemas was enough to drive accessory limb outgrowth.
I guess that's why you guys are the experts. So I get that we'll be building an arm because it's the right thing to do in this situation, and my axolotl will still be happy and healthy. Thanks for helping me understand this biological process, guys. No problem, Miss Sal. We'll do our best.
By the way, Devin, what does this person feed an axolotl for again?
I don't know. I'm sure the boss knows.
The next day.